Okay, so today we're going to be doing solving systems of equations by graphing. Okay, on each equation or on each problem you're going to have two equations, and we're going to graph not only one line but both lines, and we are going to observe or see where they might possibly intersect. If they intersect at one point, then we have a system of equations that has one solution. If they become our parallel lines when we graph them, that's going to be a no solution problem. And then if we get one where we've graphed one exact line, the same line, that's the answer would be infinitely many solutions. So the first thing you need to do when you do this is look at your two equations and see if they are in slope-intercept form. So if you look at one has the equation of y is equal to 2x plus 5. And the second equation is x plus y is equal to 2. Now ask yourself, is the first one, y equal to 2x plus 5, in slope-intercept form? And I'm going to remind us what slope-intercept form is. Slope-intercept form is y is equal to mx plus b. So is this equation right here, is this in slope-intercept form? And we answer, yes, it is. My m is 2. My b is 5. Okay, then I look at the second equation, and I ask myself, is this second equation right here, is this in slope-intercept form? And my answer to that would be no, it's not in slope-intercept form, so I need to do some work in order to put it in slope-intercept form. Oh, gotta put that x back. Okay, so what do you do in order to put this equation in slope-intercept form? Is I am going to get x by itself on one side. So I'm going to take the x and I'm going to subtract x from this side and subtract it from this side. This becomes 0. There's no x over here. There's just a y. And then I'm going to reorganize this and put the y in front. So I'm going to carry the negative with it. So negative x plus 2. Now is this equation right here in slope-intercept form? And I say that yes it is. So I have to identify my slope, which my slope is -1. There's an invisible 1, and I'm going to put it in there. There's an invisible 1 in front of this equation, or in front of this variable, invisible 1. So my slope is -1, and my b is 2. Okay, so now I have all the information I need in order to graph both lines. So the first equation I did in red, so I'm going to go ahead and create that line in red. I'm going to go to my graph, and I'm having a little bit of a hard time figuring out how to graph this neatly, so bear with me. Where's my beginning point? My beginning point is on the y-axis. So I'm going to go up and I'm going to place my point at 5, positive 5 on the y line. So it's 1, 2, 3, 4, 5. And that's my beginning point right here. And then my slope is 2, and we make it 2 over 1. So we're going to go up back to my beginning point right here, and we're going to go up 2 and over positive 1. Up 2 and over positive 1. You can go back down to your beginning point and go down to 1, 2, and over negative 1. So go down 2 and over -1. Pushing too hard. 1, 2, and over -1. So now I've got my line that I'm going to graph, and I'm going to extend the line straight through. And it's not a very straight line. I've got a lot of practice to do with this pen. Okay, so that's my first line that's in red. That is my y is equal to 2x plus 5. Okay, now I'm going to graph the second line, which is my beginning point of the second line is positive 2. So I'm going to go up 1, 2, and there's my beginning point. And then my slope is -1, and it's going to be over 1. So I'm going to go to my beginning point. I'm going to go down negative and over positive. Down negative over positive. Down negative over positive. I'm going to go up positive and over negative. Up positive over negative. So now I've got like four dots here. It's good enough for me to connect. So I'm going to go ahead and connect that. And again, it's not very straight. And hopefully I will get better. Okay, so that's my blue line. And now, in order to answer this, we want you to come up with a solution. And our solution is where the two lines intersect if they do. And it looks like they intersect at this point right here. This is a solution that has, or a set of equations that has one solution. So my solution is my ordered pair. And I look at my graph and I say, okay, it went over negative 1, so that's my x, negative 1, and then I went up 1, 2, 3, and I went up positive 3. So that is my answer by graphing these equations right here. Okay, now we're going to go to the next one that you have. And again, we're going to look to see if it's in slope-intercept form. We have our two equations, x minus 2y is equal to negative 6, and y is equal to 1/2 x minus 1. Okay, so looking at this first equation, is this in slope-intercept form? And we again tell ourselves, no, it's not. I need to do a little bit of work before I get it there. So first thing you're going to do is subtract x from both sides. So we're going to subtract x from both sides because we need to go across the equal sign. So I'm subtracting x. I've got a 0 here. I have a negative 2y. I'm going to move my x in front, so that's going to be negative x minus 6. Okay, next step, I need to get y by itself, so I'm going to divide by negative 2. I'm going to divide by negative 2, and I'm going to divide by negative 2. Negative 2 over negative 2 is a large and in charge 1. So this is a 1y. I keep the equal sign. Okay, there again, there is an invisible 1 in front of this x. So I've got to put my invisible 1 there. So now I have negative and negative is positive, and it's going to be 1 over 2 x. Negative and negative is positive. 2 will go into 6 3 times. Now I have my new equation. Is this equation in slope-intercept form? And I tell myself, yes, it is. My m is 1/2, which is my slope, and my b is positive 3. So that's the information I have for this one to graph. So I'm going to go ahead and figure out the second equation, and then I'm going to go into my graph and graph it. Okay, I asked myself, is this equation in slope-intercept form? And yes, it is. It is in slope-intercept form. My m is 1/2. My b is negative 1. Okay, so now let's go ahead and go back to the red line and let's graph this. So my beginning point we said was 3, so I'm going to go up to 3 on the y-intercept. 1, 2, 3. That's my beginning point. And now my slope was up 1, positive, over 2. Up 1, positive, over 2. Or I could go down 1, negative, and over negative 2, because a negative and negative is also positive. So I'm going to go ahead and graph my line again. It's not going to be perfect by any means. So I've got my first line, it's in red. Okay, I'm going to go ahead and now do my second line. Again, we said that our beginning point on this one is negative 1. So I'm going to go down here to negative 1, and that's going to be my beginning point. My slope is 1/2, so I'm going to go up 1 and over positive 2. Up 1 and over positive 2. Or I could go down 1 and over negative 2, because two negatives make a positive. I'm going to go ahead and graph my blue line. And what do we notice about these lines? These lines are parallel. Do they cross at any point? And they don't. So this is a graph of a solution that shows, and I'm going to change the color to black for my answer. This is a no solution because there is nowhere that these two lines will touch or will ever touch. So there's no solution that will be an answer for both of them. Okay, now let's go down to the final problem. And the final problem, I do the same thing. I look at the two equations and I ask myself, are they in slope-intercept form? And I'm looking at the first one. It says 2x plus 3y is equal to 6. That is not in slope-intercept form, so I need to make it that way. So I've got a little bit of work to do. I'm going to subtract this 2x and put it on the other side. Okay, this is 0. I have positive 3y is equal to, and I'm going to move the x in front, 2x plus 6. Oh, let me fix that a little bit. That 6 is kind of rough. So plus 6, and I want to get 1y, not 3y, so I'm going to divide by 3, divide by 3, divide by 3. Okay, the 3 becomes a larger than charge 1. 3 over 3 is 1, so I have 1y. Negative and positive is a negative 2 over 3x, and then 3 will go into 6 2 times, and it's positive 2. Again, let's identify our slope. Our slope is negative 2 over 3, and my b is 2. So therefore I have all the information I need to graph this line. So I'm going to go ahead and separate these so we don't get them confused. This work is for this side. Now let's go ahead and do the next line, our blue line over here. Is it in slope-intercept form? And it's not, so I need to do some work to get it there. So I'm going to subtract 4x from both sides. I need to do the opposite. So the opposite of positive 4x is negative 4x. This becomes a 0. I have 6y on this side. It's a positive 6y is equal to, and I'm going to bring the negative 4x in front and keep the positive 12 at the back because I want to put it in slope-intercept form. Y equals mx plus b. Now I need to make it a 1x, not a 6x, or excuse me, a 1y and not a 6y. So I'm going to divide this by 6, divide this by 6, divide this by 6. So 6 over 6, again, is 1. So it's 1y is equal to, now I got 4 over 6. Can I reduce 4 over 6? And I can. I can divide both top and bottom by 2. So this is going to be a 2 over 3x. Will 6 go into 12? It will. 2 times. Okay, so my beginning point, or I've got it in slope-intercept form, y equals mx plus b. My x for this one is negative 2 over 3, and my b is positive 2. Okay, so now I'm going to go back to my red line, and I'm going to graph it. Hopefully you see something already about these two lines, but let's go ahead and graph it and prove it on our graphs. So my beginning point is 2. 1, 2, that's my beginning point. This is the red line. I'm going to go down negative 2 and over positive 3. I'm going to go down negative 2 and over positive 3. We'll do it one more time. All right, I'm going to go back to my beginning point. I'm going to go up positive 2 and then over negative 3. And a negative and a positive make a negative. So I'm going to go ahead and graph this line. Again, it's not very straight, but you'll get the idea. Ooh, that's really rough, but it's okay. We get the idea. Okay, I'm going to go back up now, change my color. I've got my b, which is also 2, so I'm going to go back here to 2. And now my slope is going to be down 2 over 3, down 2 over 3. And what do you notice? We're exactly ending up, on up here, up 2 and over negative 3. We're ending up on the same line. So this blue line is exactly the same. Whoop, another crooked line is exactly the same as the red line. So this one is going to be what we call infinitely many solutions. So every single point on this line is going to make both of these equations true. Alright, so now you can go ahead and do your work in this section.